Hi students, today we go with the activity of a radioactive substance. Okay, so what is the activity of a radioactive substance? Means actually radioactive substance it disintegrates. Okay, the meaning of the radioactive substance means what? It disintegrates the radiation. So that is its work. Is it not? So it disintegrates is nothing but its activity. Okay, how it activity is, how it works. Okay, how the radioactive substance disintegrates with respect to time or with respect to some other factor, how it disintegrates, we call that the activity of a radioactive substance. Okay, so the activity of a radioactive substance is nothing but the activity of a radioactive substance is the rate of decay or number of disintegrations per second. Okay, so radioactive substance means what? It disintegrates. Is it not? It disintegrates with respect to time is nothing but what we can say the activity. Okay, so number of disintegrations per second is nothing but the activity of a radioactive substance, which is denoted by A. Okay, so as per the definition, we can say A is equal to, that is nothing but the activity. Okay, activity is equal to, what is in the definition? Number of disintegrations per second. Number of disintegrations depends upon the number of atoms. Is it not? So the disintegrations can be written as dn and per second, that means nothing but with respect to time, right? So we can write this as dn by dt. Okay, and we know that n is equal to n naught e power minus lambda t. Okay, we know that this, no, right? So just substitute here, that is a is equal to d by dt of n is what? N naught e power minus lambda t. Okay, so right, what we get after differentiation, we get minus lambda n naught minus lambda n naught is a, we know, constant, it is a number. For e power minus lambda t we are doing, right? So for e power minus lambda with respect to time, no, so minus e power minus lambda t. Okay, so this is the activity, number of disintegration. So we can't get the value in negatives, so I am writing a mod for this, and what we get here is lambda. Okay, lambda n naught e power minus lambda t is what again? N, is it not? So I am writing n here, lambda n. Okay, so the activity A can be written as what? Lambda n. And if A naught is the activity at time t is equal to 0, where number of molecules are, number of atoms are n naught. Okay, so now we'll go with that. If A naught is the activity, if at the initial time we are doing, this is at any situation, okay, at any time we are doing, and if we want to go with the initial time, that is t is equal to 0, right? So if A naught is the activity, when A naught or n naught or the activity or a number of atoms, when means time t is equal to 0. Okay, so we can write this as, so here what we get, A is equal to lambda n, so we can write A naught is equal to, lambda is decay constant, so that is lambda only, and n is what we can write this as n naught. Okay, so just we'll write A is equal to lambda n, take this as equation 1, okay, and this as equation 2. Okay, we want the particular activity of a radioactive substance, so I am doing like this, equation 1 divided by equation 2, right? So what we get here, A by A naught is equal to lambda n by lambda n naught. So lambda gets cancelled. N is what? N naught e power minus lambda t, by here it is n naught. So n naught gets cancelled. What we get? E power minus lambda t. Okay, we want a or a naught, we want a, right? So what we get here, a by a naught is equal to e power minus lambda t, and a is equal to a naught e power minus lambda t. Okay, so see here, n is equal to n naught e power minus lambda t, a is equal to a naught e power minus lambda t. Comparing these two equations, which shows that the activity has same time dependence as n. Okay, activity, how n number of atoms after some time, how n depends upon time t, as well the activity also depends upon time t. So a is equal to, what we get here is nothing but a naught e power minus lambda t. This formula is very very important. Okay, so a is the activity at any time, a naught is the activity at the initial time where t is equal to 0, and okay, lambda is the decay constant and t is the time here, right?